Alright, so I took a little bit of resin and I plugged these two little guys together here. And so they're pretty stable. They're not perfectly straight, but I'm not going for perfectly straight. Not with this design. I also found that I was going to do a solder line. Take a look here. Can't really see it, but I was going to do a solder line across the top here and just connect all the nubs where I needed to connect them. Because each half of this, I don't have to connect these because each half of this board is actually two separate halves, which is great. The only downside is I can do that up here, but I can do that down here. I can't do it in between because they are too close together. And a solder line will connect all of one of these pins and completely destroy that half of the connection. Which means I'm going to have to do individual wire connections between each of these little nubs. And that's going to get messy and ugly and crappy. And I bought a whole skein? Is that how you do it with wire? I bought a whole collection / looping of wire. And then a couple of days ago I had a PSU blow out on me and I was about to throw it away and I grabbed it by the connecting cables and I went towards the garbage can and I said, wait a minute, I can use this. And so I'm going to. This is actually not dissimilar to the wire that I purchased. I believe it's solid core. So it's just a bunch of solid core wires that leads to the ATX connection on a PC, on a motherboard. And there's enough wire here because I don't need long connections. I only need very teeny tiny, very short connections for this board. And so because I'll be going from, say, here, this pin here, and it's very far away from the camera, but I'll be going from like this pin here to this pin here. So I need like that much. Even that, I mean, once I strip the two ends, it's just going to be a little sliver of actual shield. And so I was thinking, like, what color should I use for this? Like, which color should I use? Should I use this color or that color? And I figured it really doesn't matter. I mean, I can differentiate the size of the board with color, and I can differentiate the board itself with color. But I have a lot of red, a lot of black, a little bit of orange, not very much blue or yellow. So I'm probably going to end up using not the designated color codes that you're supposed to use, probably just random color codes. And that will get me, hopefully, to a point where I need to be with regards to, let me go ahead and, I think this is the only purple wire. Purple wire, let's go to snip. So yeah, I mean, this is a lot of wire. So since it's going to be going across the board, I would only need one of these to go all the way across and then split it and do it on the other side. That's going to take a little bit of time in soldering. More than the soldering part, the big time waster is going to be snipping and stripping these wires. So that's going to be my next big thing. Then, in case you guys are wondering about the camera angle and lighting changes, this is one of those few times when not everything I did was recorded all in one session. A lot of what I'm doing is I completely forgot. Yeah, I had completely forgot that I did this, and then I cleaned it, and now it's dirty again. This is being done in multiple sessions, so I know where I'm going, but to record it, it's a new experience for me. So if the camera keeps jumping all over the place, if my editing is really bad, if my lighting is terrible, and my angles are trash, it's simply because I'm trying new things because I forgot what I did last time. But right now, what I have now is a board that is JB welded together with a little bit of epoxy, and a lot of buttons, and some spare solid core wire I can probably use for this project. And I need to count out the wire because I know I've showed it. At some point in this video I'm going to show it. I'm going to mention it several times, but I do have the wiring diagram for this. I found one that works, or that looks like it works. I've tested it. It seems to function properly, and it's really easy for me to follow. And so I'm going to use that one, and for that I just need to count how many snippets of wire I need. And it's 2 halves of 5 buttons. Yeah, 2 halves, 5 buttons, 4 rows, 20 connections per side. So I need at least 40 snippets, and then at least 12 long cables, roughly the same length cables, to connect to this, because I need 4 for the, or 5 for this. Yeah, 5 for this and like 8 for this, right? Yeah, 5 and 8. 13, I guess, connections. So I need 13 wires to stick out. And I'm going to follow all that in the wiring diagram, but it's not something I'm going to do on camera. The solder, I'll show off the soldering, things like that. But when it comes to like snipping the wires and doing all that, that's gonna be a long and boring process. So I'm just gonna do that off camera in my spare time, and then you guys will see the results. So after a couple of tries with the wire from the power adapter that I had taken apart, it turns out that frayed nature of the wire, I guess you could say, is not up to par. The wire is actually absorbing all of the heat from the soldering iron. It is melting the plastic. It is burning my fingers. And in order to get it to even stick a little bit, I have to tin the wires individually on each side using a helping hand system, which is just all up in the way and can't be recorded. And if you take a look at the board there, I do have a small blue wire up there. That is a piece of the solid core wire that I purchased for this project before I decided to use some scrap wire. And I was able to get that soldered into place in under 3 seconds without a single problem, and the wire bends and holds its shape just fine. So I'm going to go ahead and actually redo everything I just did with all the threaded wire. I have no idea what it's called, but basically it's the multi-core wire instead of solid core wire. And I'm going to go ahead and yeah, redo. And it turns out I actually need more pieces than I originally thought. I thought I only needed 40. That might be 40 for the buttons across, but that's not 40 for all the buttons up and down and all the main wires that go to the board. So there's a lot more wires that I need. So I'm not close to done yet. But I want to let you guys know of a small update as to why I switched wires and why there's a horrible mess there. And yes, I did in fact burn my hand. The trials and tribulations of customizing one's ancient computer. So let's get back to it. Okay, so here we finally are. So first thing I'm going to throw at you is this. This is the original keyboard for the Sinclair with all of its wonderful nubby little keys. And I am going to now flip this over and kind of do that with it so you can kind of see what's going on. These are all the connections and everything. And the reason I point that out is because here is my keyboard, or the keyboard I have built. And as you can see with all the wires coming out of it, it looks kind of like a spider's nest. That's what it's going to be looking like on the back. So as a out of focus demonstration, because again, I do not have autofocus turned on. So that's what that looks like. Now, as you can see on this side, a little bit hidden under here, you have several non-red wires. That's because as I got towards this side of the board, and you can see it got kind of cramped, and it had this kind of S-curve going on with all of these. But when I got here, these blue lines that I had soldered on were actually
too long and they dipped down a little bit too far and they got a little bit too close to these solder joints for the other pins. So I ended up just stripping teeny tiny lengths of wire and then soldering them between where they needed to connect, because basically this row connects to this row all connects, and this row all connects, and the button swaps them across. So it doesn't really matter which two nubs on this side I attach to, as long as it's from one button to the next. And so I was like, oh, okay. It took me to get to about here before I realized that, and then I tried it on here, and it turned out working with teeny tiny little nubs of metal on a soldering board with plastic wires you can melt was very difficult. So I did that one row, and then I went immediately back to the other one. As you can see, some of my plastics melted. So this is a terrible job. Again, out of focus because I drifted. So that is a terrible job, but it absolutely works, at least good enough for me, because I'm that kind of a person. I'm going to assume somewhat in focus. So now it has come time to actually test this. And we are going to take the case, and we're not going to put it all together or anything. I've actually scratched the top of the case quite a bit by continuously setting this on top of it, which has created a situation where it keeps scratching it from slippage. So we're just going to set this down right here, and we're not going to like put it all together or anything. There's no point for that. Now the problem I'm having here is that, as you can see, I have all of my wires. Now I went with white wires for my out, so I just wanted to be consistent. I have a lot of wire and color and things like that, and I thought about even making multiple colors for this, but I didn't. The problem that I have is each one of these lines is supposed to go into here, and it's split in a very interesting fashion. These are all the D lines, and these are all the keyboard lines. Now, these are supposed to be the keyboard lines in the middle, I think. No, I'm sorry. These are supposed to be the keyboard lines here, because it's just the 5, and that's the keyboard here. And then these are the D lines, and you have D0 through 4 and whatever, but it doesn't go like 0, 1, 2. It goes like 0, 1, 2, and it goes back and forth. And both schematics that I looked at made it look like the way I soldered this board was correct. However, I will admit that it was hard to find the schematics for this board, and the two that I found may not have actually been for this particular Timex. And taking a look at the back of my board here, the original one that came with it, which I don't know if it works, so it may not. You can see where these fit across to connect this half of the board to this half of the board, very similar to my design. See these two center ones here? They're not connected. I mean, technically they're connected. Well, I guess this is a connection. This is a lower level connection, so maybe they are connected. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Now I'm less paranoid, because when I looked at this before and I saw these curved ones, I was like, oh, these two aren't connected. I screwed it up. But no, they are connected. So this should actually work. Should work just fine. But the issue here is, as you can see, these 4 lines here, 1, 2, 3, 4, don't all go to the same place. So these 2 top lines here go here, and then these 2 bottom lines here go out, and they actually go to the 3rd and 5th, 6th, something like that, 5th, I think. So it's like 1, 2, 3, 5 for this lane. And then this lane is pretty simple. It's 8, 7, 6, 5, or 8, 7, 6. No, 4. As you can see, it's kind of hard for me to visually track, and I haven't gone through it all. So I may plug this in, and the buttons just won't be the buttons they're supposed to be. But the question is will this work? Now, all I have right now is raw wire. That's all I have. Now, I did purchase some items to correct this situation, which are these lovely little guys right here, which are several sizes, but the ones I wanted were 4-pin and 5-pin. Now the reason for the 5-pin is simple, because 5-pin is 5-pin, 5 for 5. Now this is 8, so of course you need, well, you would need an 8-pin, which I don't have in this kit, but I do have 2 4-pins, and I can just, except I can't. Now these were also bought for a separate project, and I went out of my way and I measured that other project, and they fit perfectly fine. They're like 1.2 millimeter distance between each pin, I think is what it is. It might be less or more, but I measured it and I know what it's like. Downside is that's, you can't really see it. You can barely see it. But if I match this up, we're about 1 pin off on 5 pins. So this is a 5-pin connector, and it's, it's 1 to 1, but, and it's out of focus again. But basically, if I line each pin up directly, I'm 1 pin off. So these don't match up directly. So that gives me kind of a conundrum. Wrong one. Gives me kind of a conundrum. Gives me kind of a... I need to think of an idea of how to connect these wires to this body more betterer. Because right now what I can do is I can simply jam the wires in there. These were made for paper thin ribbon cable, and these are like 1 point some odd millimeter thick connectors. So I can do that, and it is an okay temporary test connection. So that's what I'm going to do. Now I do have the option of soldering it in place. I don't want to do that. I have the ability to bodge it a little bit by putting a 5-pin or 2 4-pins in there and misaligning them slightly and bending the pins and doing a little bit of work like that. So there's some things I can do, or I can 3D print a new one. That I'm not really keen on because I use a resin 3D printer, and unlike filament printers, resin printers are a little bit more fragile, a little bit more brittle, and something this tiny, I plug it in once, it might work fine. Try to plug it in a second time or unplug it, it could shatter. It could shatter the first time. So because of that brittleness, and because I'd have to make the bottom half of the shape, or I could like make the top half and then insert it, but then I'd have to insert the wires, and it's really complicated, and I really haven't thought too much about it. Because right now my biggest concern is to make sure this works. Now what I'm going to do is I'm going to take some of my time, not your time, I'm going to take some of my time, I'm going to plug these wires in as best I can based on this and my diagrams. And then we're going to plug it in, and I'm going to do that uncouth thing that I do sometimes, which is I would have to point this little guy, or excuse me, point that little guy at my monitor because I can't capture the signal from this because I don't have a capture card that can take an analog signal, or at least not one that runs on a computer that is modern enough to take an analog signal and capture it. So I'm going to do that, and we'll be... Okay, and after a bit of bodging, this is what I came up with right now. And the reason why I have the man in the middle going on there with my breadboard is because when I tried to put these wires into there, they were so stiff that I kept bumping them out of the way. And the connection in there is extremely tenuous to begin with because it's just tension pushing on a wire, and so if it wants to push it left or right, it's going to. Also, these breadboard wires are much thinner, and they're designed that way specifically so you can push them into weird places like this. So I have all the wires hooked up. I have them spread out by one distance here. I'm pretty certain I have all these in the right place. If I don't, worst case scenario, I'm just going to get the wrong button press. But I'm hoping that the buttons I press will be correct. So I'm going to have to adjust the camera to point it at the screen. That's going to be kind of a... I do apologize for that ahead of time. I am actually going to apologize for the fact that I do have to point my camera at a screen because I can't capture. But before I do that, I am going to plug in a couple of things. The first thing I'm going to do, though, is get my... There you go. Get that to move. So I have this. I'm going to try to do this without... Now that I have to move things around, I'm going to try to do this without messing too much up. There you go. Okay, so that goes to my RF connector. My little sliced together one. And then the power, 9-volt DC, is in the front, all the way in the front. So I don't want to touch anything when I do this. I just want to push it in and see what... there's like literally no place I can... I think this is ground. It was a heat system, so it's close enough to ground. It's actually making noise. But I'm not getting a good video signal. Is it because I'm on channel 3 and not channel 2? Go down to channel? Channel 2 is not more helpful. Uh-oh. Uh-oh. I bumped a cable. Okay, I think I'm supposed to be on channel 3 because I never changed the channel. I never changed the channel in the back. Okay, so I got garbage. I'm hoping that's not from the sync sitting or me handling it. I think it's just the monitor does not want to actually give me a video signal of any kind. The other downside of that is when I had the video signal last time, it was very bad. Something easy. Nope, just wants to give me static and noise right now. Okay, so I'm not getting a VSync hold on this. I'm getting some very staticky sound. I don't think the board's broken or fried or busted in any way. I haven't been handling it, it's just been sitting. I know they can go bad from just sitting too, but I also know that it was working before, but very poorly. It could be because of a bad signal. It could be because this monitor has decided it doesn't want to do. Yeah, it says weak or no signal, so it's just not getting a strong enough signal. So let me fiddle with it a little bit and see if I can get a signal to show up, and then, or a signal to show up in something. I'll find something that a signal will show up on. We'll see if we can get a signal to show up, and then I will, I'll be right back. Yeah. No, it's not lying to you. I turned off all the lights, and I had to because that fuzzy little black dot in the corner is all the signal I can get out of this. Now that's normal. That's how it acted last time, but I really needed to bump this. I think I'm gonna have to bump the exposure up a ton for you guys to even see it. Let me. Okay, so it's because the exposure is so high, the frame rate's gone to crap. But that's what I see there. I'm gonna have to turn that back down again. That's too normal, right? So yeah, because of that, that is all I see. So I'm gonna have to hold this camera as steady as possible. It is in my hand, so it is wobbly as all hell. And I'm gonna press what I hope to be the V key, which should show up as a CLS on the screen. Let's find out if I can do that. So press down on this button gives me nothing. Okay. That's that's upsetting. Okay, none of these buttons. No, don't tell me all this work for nothing. Ah, the sadness. Okay, I'm not getting anything out of these buttons. I should be getting, if nothing else, I should be getting garbage. I know the connections work. Oh, great, it's gone color. Now you guys can't see a damn thing. Luckily, my human eyes still can, so I'm going to stop torturing you with this, and we'll go back to me crying over the fact my keyboard's not working, so let me put this back where it belongs. Okay, so a couple of things. First, I finally found a signal that my main television, a Sharp Acuos, cannot accept, and that is the signal from a Timex Sinclair. I thought because my TV is good at decoding any signal, it can decode Amiga, DVI, VGA, RCA, RF, blah, 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 blah. I thought to myself, well, if it can do that, this tiny Samsung monitor over here can not do the Amiga, but it can do my, my TV can. Why don't I just plug in this over there and maybe I get a bit of signal? Plugged it in, it blipped once, could not capture anything, just stayed on snow. So I finally found a signal that my Sharp Acuos cannot decode, which is a signal from a Timex. Another thing is I thought I had wired the breadboard incorrectly and I was somehow causing a short because every once in a while I'd push a button, mainly the number 1 button. I'd push the number 1 button. What would happen was the screen would get lighter, like more power was being added, but nothing would show up on screen. So something was occurring when I pressed the button. I did also find out that a lot of these buttons that I cut and shaved, they're finicky now. They work, they click, that's the point, right? You click, that means one piece of metal presses into the other piece of metal should work fine. Apparently, they're a little bit more finicky than that, and by changing the shape and slicing down the buttons, some of them are a little bit more nope than yep when you press them. The regular buttons on there still work perfectly fine, like my 1 button. This is a 1 button over here. It works perfectly fine. I then took all the wires out and I put in exactly 2 wires. I put in the connecting points between this side and this side for the number 1. I pressed it and something popped up on screen. I don't think it's a 1, but it's really hard to tell, and that is actually causing me more problems than whether or not this keyboard is working. Because I don't know whether whether I'm going to have to redo this entire project. I know I'm not really pointed at the board right now, but I don't know whether or not I have to redo this entire project. Or if I have to, if everything's working fine, but there's something in my wiring or soldering or something. But here's where the more bigger problem comes in. Is if I can't see what's going on screen, I don't know if I'm wiring this properly. I don't know if my wires are in the right place. I don't know if there's a short. I don't know if all the buttons work. I can't test them. And the signal's only lasting about a minute, maybe a minute and a half before it completely shorts out and I have to reset the board, get a fresh signal. If it catches that signal, then it works again. And that is really annoying. Now, there is an RF modification for this. This is using an RF out, which goes to cable. It's going to this RCA cable, but this RCA cable is connected to another RCA cable via an extension, which is connected to an RF jack via a splice, which is something I did for my C64. So this is actually outputting the same signal as a cable box or an antenna would. And there's a mod that you can pop this open, solder a couple of wires in, strip a couple other wires, and boom, you have an RCA connection, or composite, basically. Component? I always get those two mixed up. Anyway, you have that, except there is a very specific video chip used in the Sinclairs that doesn't work with. The signals are different. They come off of different lines or something like that, and that doesn't work. And while I was researching, it said the American version of this does not have that problem. It does not use these chips. I must have been special, because both, not one, both of the ones I got in this purchase have the chip you cannot modify. So I cannot, I want to, I've wanted to, I haven't tackled it because I've never done it before, but I wanted to replace or swap this little guy out. Again, you guys can't see what the hell I'm pointing at. I wanted to swap this little guy out because this is not working for me, so I wanted a better signal. Turns out you can't. Turns out you cannot. Now, I do have a tube TV that could absolutely take the signal at its lowest frequency and pop it up on screen for me, no problem at all. But it is in a completely different room where I cannot record. I would not be able to record anything, and taking this whole kit in there would be a big pain in the butt. Even if I were to like slide it onto a plate or something and carry it in there, it'd just be such a pain in the tail. And the TV weighs about 700 pounds. I am not kidding you. It's like a 750-pound television set. So scooting it around to get this cable plugged into the back would not be something I really want to do. I mean, it is an option, but it's one of those last resort options. So what I'd like to try to find more than anything else in the whole wide world is a very simple, either make one or buy one, RF amplification unit, which is basically an inline amplifier. It takes a signal in, amplifies it, pushes it out. And signal amplifier should give me a strong enough signal, maybe not a good enough signal if this is shorting out or the grounding wires or something are bad on it. And my center of camera is really bad right now. I'm not even looking at the screen half the time. But I can take this and instead of modifying it, just add an inline. Just put some kind of inline, cheap, $9 whatever. The problem is nobody makes them anymore. I don't have one, oddly enough. And I could probably find one at a thrift store, maybe, but they're super rare to find. Super rare to find. You're more likely to find a basic splitter than you are to find any kind of RF amplifier. But you can still buy them. You can still buy them online because there's still places that use antennas and things like that. So and if you're using an antenna, you need a signal amplifier. So they do exist, but they're a little bit more expensive than I really want to shell out. They're not hugely expensive, but they cost money, and it costs a bit more than I want. So I am going to look up a way to modify this on the unmodifiable chip. I think there is a way to do that, but you don't get to do it the common way. You have to do it the complicated way. And I'm like, hey, a little bit more effort on a board I haven't been able to play with yet. So I have a couple of options there. So for now, we're going to go ahead and cut this because the board is soldered together, but I am at a point where I cannot continue, nor can I shunt off until I have corrected this problem, which is something I was hoping I wouldn't have to do right away. Probably should have done it first, honestly, but, you know, I wanted to solder a board together. So here we are. I soldered it together. Everything's good to go. Well, everything is good to move forward for additional testing if the video signal works. So I will be doing this part next. I think I'm going to have to do some research. I may be able to take the whole thing out, maybe able to pop the top off, move some things around. But this is one of those things that it's, as of this point in time, it is above my knowledge base. I have never had to deal with one before. I almost had to deal with one with my Commodore 64, but they sell a cable that you plug right in, and you completely bypass the RF signal system. So I didn't have to do it. I almost did, but I didn't have to. So that was the closest I ever came. But this one I'm going to have to do something to get that signal boosted. And I will figure out what that is shortly. So haven't really gotten that far. It's been a long while me working on this. But I do feel like I've at least gotten to a point where now I have a better plan. And if I can get this working, and then I can get this working. And in worst case scenario, if I can't get the keyboard working the way I want, there are alternative options for this keyboard. The simplest one is to go through like a PCB manufacturer and get more PCBs than I need, but get a PCB manufacturer to manufacture me a basically this sized PCB with all the traces where I need them without me having to solder anything. I just solder. Well, I would solder in the buttons, or I could have them do it. You can pay them. Some of those places will actually solder them, so I could actually just order a replacement keyboard of this style if I wanted to do that. If it was too much of a pain to either fix this, or if it doesn't work, or whatever, I could just order a brand new one, um, and do that. But I do want something else other than this. I do want something other than this flimsy little. Let's see here. Even if I got an exact replacement made from modern materials, they don't last long. They were never meant to, and they're not comfortable to use. And I think that a customized one would be more fun. So we're still going to be working on that. But next thing is going to be this guy. So for now, though, I would like to thank you all very much for joining me, 4 kilobytes short, on this episode of Short Circuits, and I will see you guys next video.